Yesterday, a volcano sitting just 4 kilometers from a Japanese city of several 100,000 people erupted and buried it in ash. That volcano is Sakurajima, one of the most active on Earth, and the plume climbed thousands of meters over Kagoshima before authorities issued an official ash warning. But the eruption itself is not the alarming part. The alarming part is what is sitting directly beneath that city, a buried system 30,000 years old, that is, right now, quietly recharging. By the end of this video, you will understand exactly what Kagoshima is really living on top of, and why it matters. Let's get into it. Yesterday morning, one of the most active volcanoes on the planet erupted directly over a Japanese city of several 100,000 people, and within a couple of hours, the streets of Kagoshima were buried under a fall of volcanic ash. This was the Sakurajima volcano in southwestern Japan, and the footage that came out of it looked less like a normal eruption and more like a city being swallowed. A dark column rose behind the high-rise apartment buildings. Ash came down across the roads, the cars, the rooftops. Visibility dropped. And Japanese authorities did exactly what you would expect a prepared nation to do. They issued a volcanic ash warning for the city, and they kept the volcanic alert at level 3 on a 5-level scale. Here is the fact that makes this story matter, and it is the fact you need to hold on to for everything that follows. Sakurajima sits roughly 4 kilometers from the city of Kagoshima. That is about 2.5 miles. You could see this volcano from a downtown window. You can reach it on a normal day by a ferry ride of about 15 minutes. And about 4,600 people live directly on the volcanic island itself. So when this mountain erupted yesterday, the people of Kagoshima did not watch it on a screen the way the rest of the world did. They walked out into the ash. But the eruption you saw yesterday is not actually the most alarming part of this story. The most alarming part is what is sitting underneath this volcano, and we are going to get to it. First, let me tell you exactly what happened, because even the timeline of this eruption tells you something important about how these mountains behave. The eruption began in the early hours of yesterday morning, local time, and here we hit our first complication, one I want to be upfront about. The official monitoring agencies, the ones with the seismometers and the satellite feeds, logged a principal explosive event that ran for roughly an hour, from about 6:52 in the morning to about 7:55, with the ash plume rising on the order of 1,300 meters above the crater. That is about 4,300 feet of ash standing above the summit. But other reporting described something longer and larger, an eruption that began around 5 in the morning and continued in pulses for as long as 7 hours, with the plume reaching as high as 3,500 meters, around 11,500 feet, and by some accounts even higher. So which is it? The answer is that both are probably true, and the reason is worth understanding. A volcano like Sakurajima does not erupt the way a bomb goes off. One clean blast, and then silence. It pulses. It surges, and it eases, and it surges again. So, you can have one discrete, violently explosive event that an agency timestamps to the minute, sitting inside a much longer window of fluctuating ash emission that people on the ground experience as one long, grinding morning. The instrument catches the spike. The human catches the whole ordeal. Neither one is wrong. What everyone agrees on is the part that matters. This was a large, significant eruption. The ash drifted south, and one advisory tracked it about 56 kilometers, roughly 35 miles, south of Kagoshima Airport, at an altitude near 3 kilometers, about 10,000 feet, which is exactly the kind of thing that grounds aircraft. And it was big enough that the government of Japan, a country that does not issue warnings lightly, told an entire city to take the falling ash seriously. The direction the ash traveled matters as much as the height it reached, because where the ash goes decides who suffers. Yesterday, the plume drifted toward Kagoshima City and to the south, which is exactly why the city took the brunt of it, and why the ash warning was issued for it specifically. The wind is the wild card in every Sakurajima eruption. On a day when it blows the ash out over the empty bay, an eruption of a given size is a minor event. On a day when it carries that same eruption straight over the city, it becomes a major disruption. Yesterday was an unlucky day for Kagoshima, with the wind delivering the ash right into the heart of the urban area. And it gets more serious when you understand what that ash actually is. Volcanic ash is one of the most misleading terms in the entire language of disaster, because the word ash makes you picture something soft and harmless, like what is left in a fireplace. Volcanic ash is nothing like that. It is rock. It is finely shattered stone and volcanic glass, and under a microscope, a single particle looks like a splinter of broken glass, because that is essentially what it is. It is abrasive. It is heavy. It does not dissolve, and it does not blow away easily. When that material falls on a city, it goes after every system at once. It is genuinely hazardous to breathe, which is why the warnings tell people to stay indoors and wear masks, because those glass shards in your lungs are a real problem, especially for children and the elderly. It coats the roads and kills visibility. It works its way into engines and electronics. It is the reason an entire global network of volcanic ash advisory centers exists, tracking these plumes specifically to keep aircraft away from them, because ash can melt inside a jet engine and shut it down. And in heavy enough accumulation, especially once rain adds weight to it, it can threaten to collapse a roof. So this was not a cosmetic dusting. This was a multi-system assault on a working city of hundreds of thousands of people. And it is a Tuesday morning the people of Kagoshima will be cleaning up from for a while. And yet, for this particular city, even an event like this is, in a strange way, routine, because this mountain never really stops. To understand Sakurajima, you have to understand that it is not a normal volcano having a dramatic day. It is an extraordinarily active volcano having a fairly typical one. Most people picture a volcano as a mountain that sits quiet for centuries and then erupts once. Sakurajima is the opposite. It produces minor, explosive eruptions in the thousands every single year. Near constant eruption is its resting state. On a quiet day, this mountain is still smoking. The summit has 3 main peaks. The northern one, Kitadake, is inactive. The central one is Nakadake. And the southern one, Minamidake, is the engine, the peak responsible for yesterday's ash, in a state of nearly continuous activity. And because this mountain is so close to so many people, the community around it has built one of the most remarkable cultures of coexistence anywhere on Earth. The school children of Kagoshima go to school wearing hard hats, helmets, as a routine precaution against falling volcanic rock, because when Minamidake has one of its bigger moments, it throws stone. There are reinforced concrete shelters scattered through the inhabited areas so that anyone caught outside during a sudden explosion has somewhere to take cover. There are ash collection bags, street cleaning systems, and ashfall forecasts built right into the local weather reports, telling people which neighborhoods will get dusted today. The monitoring behind all of this is relentless, because Sakurajima is one of the most closely watched volcanoes on Earth. There are seismometers listening for the tremors that magma makes as it forces its way up through the rock. There are tilt meters and satellite instruments measuring the swelling of the ground as magma moves below, precise enough to catch changes of mere centimeters. There are infrasound sensors that hear the low rumble of an explosion, even when clouds hide the summit, gas monitors sampling the volcanic emissions, and cameras trained on the crater around the clock. All of that data flows to analysts at the Japan Meteorological Agency, who turn it into the alert levels and warnings that ordinary people actually act on. That alert level holding at 3 yesterday was not an automatic readout from a machine. It was a human judgment, informed by instruments but made by experts, that the conditions warranted telling the city to take the falling ash seriously. This is a society that has metabolized a permanent volcanic hazard into the rhythm of daily life. And they have not done it through denial, and they have not done it through panic. They have done it through one of the most rigorous, clear-eyed disaster preparedness systems on the planet. But to understand why they take it this seriously, you have to know what this mountain did the last time it truly let loose. The name Sakurajima means roughly Cherry Blossom Island. And that name is a fossil, a clue to something that is no longer true, because Sakurajima is not an island anymore. It used to be. For most of its existence, it stood as a separate island in Kagoshima Bay. And then, a little over a century ago, the mountain rewrote its own geography. The year was 1914, and the eruption that began that January is remembered as the Taisho eruption, the most powerful Japanese volcanic eruption of the entire 20th century. The mountain tore open and poured out an enormous volume of lava, and as that lava flowed down the eastern flank and into the narrow strait separating the island from the mainland, it filled the channel. It bridged the gap. The molten rock cooled into new land, and when it was over, the island had been welded to the Osumi Peninsula. To this day, you can drive across that land bridge. It exists because a volcano, within living memory, connected itself to Japan. Dozens of people died in that eruption, and the memory of it is part of why the preparedness culture around this mountain is as serious as it is. So when you watch the ash from yesterday, layer this underneath it. The eruption you saw is small. I mean that precisely. In the vocabulary of what this mountain has done, an event that throws ash a few thousand meters up and dusts a city is the mountain clearing its throat. 1914 was on a completely different order of magnitude. And here is where this story turns. Because even 1914, that 20th century giant, is dwarfed by something far older and far more terrifying that happened in exactly this spot. To see it, you have to stop looking at the mountain and start looking at the bay. Here is the fact that reorganizes this entire story once you understand it. The bay that Kagoshima sits beside, the calm body of water the ferries cross in 15 minutes, is not an ordinary bay. The northern part of Kagoshima Bay is a caldera. It is the collapsed crater of an ancient volcanic catastrophe so enormous that it dropped the ground over a vast area and left a depression the sea has since filled in. It is called the Aira caldera. And Sakurajima, the volcano that buried the city yesterday, is not the main event here. It is just the most active cone that has grown up on the southern rim of that ancient scar. The eruption that formed the Aira caldera happened roughly 30,000 years ago, and it was one of the largest in all of Japan's prehistory. When a volcanic system erupts on that scale, it empties a magma chamber so completely that the ground above, having lost its support, collapses downward into the void, dropping the surface over a region many kilometers across. The Aira event produced what scientists call the Ito pyroclastic flow, a ground-hugging avalanche of superheated gas and ash and rock that races across the landscape at lethal speed, incinerating everything in its path. It laid down a thick blanket of pumice across the region, and the numbers are the kind that stop meaning anything. This eruption was hundreds of times larger than the 1914 event that built the land bridge. Stack those comparisons up. Yesterday's ash is a whisper. 1914 was a shout. The Aira eruption was a scream that reshaped an entire region and left a hole the sea is still filling. There is a way to make that scale concrete. Scientists rank explosive eruptions on a magnitude scale, where each step up is roughly a 10-fold jump in the volume of material erupted. On that scale, yesterday's eruption sits low, in the range of significant but manageable events. The 1914 eruption sits several steps higher, up in the territory of genuinely major eruptions. And a caldera-forming eruption, like the Aira event, sits near the very top, in the rarest and most destructive category the planet produces, events so infrequent that thousands of years can pass between them anywhere on Earth, and large enough to perturb the global climate for years. Yesterday's ash and the eruption that built this bay are the same system, separated by several full steps of that staircase, each step a 10-fold leap. Right now, the mountain is standing near the bottom of it. And that is the worst part the title promised you, because that ancient system is not dead. It is recharging. Scientists have been watching the floor of the Aira caldera for a long time, using instruments precise enough to detect the ground rising or falling by mere centimeters. And what they have documented over the decades is a gradual inflation, a slow swelling of the caldera floor that is consistent with magma accumulating at depth. The reservoir that emptied 30,000 years ago is, in the most literal sense, slowly refilling. That is a real, measured, documented fact, and it is why the Aira system is considered one of the most important long-term volcanic hazards in all of Japan. Now, I have to be very careful here, because this is exactly the kind of fact that careless coverage turns into apocalypse, and I am not going to do that. So here is the honest version. Recharging is not the same as erupting. A slow swelling measured in centimeters over decades is not a countdown clock. There is no scientific indication, none, that another caldera-forming super eruption is imminent. An event on that scale would announce itself with enormous, unmistakable warning signs. Dramatic changes in earthquakes, ground deformation, and gas output. The kind of signals the dense monitoring network around this volcano is built to catch, and it would do so well in advance. The honest framing is one of scale and time. The system beneath Kagoshima is loaded. It is recharging. It has done something civilization-altering before. And it is also not about to do it tomorrow. And the smartest people watching it are not lying awake in terror. They are watching the instruments. All of those things are true at once. Living with Sakurajima means living inside that contradiction. And the reason this volcano exists at all, the reason Japan gets so much of this, comes down to one process running beneath the entire country. Japan sits on the Pacific Ring of Fire, where the great plates that make up the surface of the Earth are colliding. Off the coast of Japan, oceanic plates, the Pacific Plate and the Philippine Sea Plate, are being forced downward, dragged beneath the plates the Japanese islands ride on, and back into the hot interior of the planet. That process is called subduction, and it is the engine behind nearly everything that makes Japan geologically dangerous. Here is the elegant and terrible part. When that oceanic plate descends, it carries water down with it, locked into the minerals of the old seafloor. As it sinks and heats up, that water is cooked out and rises into the hot mantle above, and it lowers the melting point of that rock, generating magma. That magma rises, and where it reaches the surface, you get a volcano. You get a whole arc of them running parallel to the coast. Sakurajima is one bead on that string. The ocean, in a real sense, feeds the volcano. But subduction does not only make volcanoes. The same descending plate also gets stuck against the plate above it, building stress for centuries until it releases all at once in a megathrust earthquake. And if that happens under the sea, it can launch a tsunami. Japan knows this cost better than almost any nation, from the Great Earthquake and Tsunami of 2011. So the volcanoes and the earthquakes are not separate misfortunes. They are two faces of one underlying machine. And that is why the people of Kagoshima are not just braced for one disaster, but for an entire interlocking family of them, all driven by the same source. Which brings us back to the most human part of this whole story. It is easy, from a safe distance, to ask why anyone would live 4 kilometers from a volcano that erupts thousands of times a year. But that question dissolves the moment you take these people seriously. Kagoshima is not a temporary camp that happened to set up next to a volcano. It is a city with centuries of history, where families have lived for generations, where livelihoods and identity are rooted in this specific place. And there is almost nowhere on Earth that is truly free of natural hazard. Leave the volcano, and you may find yourself on a fault, or a floodplain, or a hurricane coast. The fantasy of the perfectly safe place is just that, a fantasy. What the people of Kagoshima have done instead is build a life of remarkable normalcy in the presence of a genuine and permanent danger. They know exactly what this mountain is. They know what 1914 did. The experts among them know what the Aira caldera is capable of on the long horizon. And rather than fleeing or freezing, they have built a society that holds the danger in full view and goes on living anyway, with helmets and shelters and ash forecasts and ferry schedules. That is not recklessness, and it is not denial. It is one of the more impressive things a human community can do, and the constant low-level activity of the mountain is, in a strange way, what keeps them sharp because it never lets them forget what they live beside. I do not want to romanticize this, because for the people living it, this is often simply hard. The ash is unpleasant. It gets into everything, damages cars and roofs, triggers respiratory problems, and costs money constantly in cleaning and repairs. The larger eruptions, like yesterday's, ground flights and stop trains and keep children indoors. And for the 4,600 people on the island, there is always the knowledge that they may someday have to leave at short notice. This is not a charming adventure beside a picturesque mountain. It is difficult, ongoing, unglamorous work to stay safe in a place nature has made genuinely dangerous. And the people of Kagoshima do it without drama, year after year, as the price of being where they are. One more thing, before we close, because it circulated alongside the eruption and deserves a straight answer. A few days before yesterday's eruption, a bright meteor, a fireball, was filmed streaking across the night sky behind Sakurajima. The footage is striking, the dark silhouette of the volcano, and then a brilliant streak of light cutting down behind it. And then, days later, the mountain erupts. Naturally, people asked whether the two were connected. They were not. There is no physical mechanism by which a meteor burning up high in the atmosphere could trigger or foreshadow a volcanic eruption days later. The energy of a fireball is tiny and deposited tens of kilometers up, with no path to the magma below. It was a coincidence, a striking image with no causal story behind it, and the honest answer is to say so plainly. So here is where this stands, and what to watch for. Yesterday's eruption was a notable but characteristic event from a volcano that is almost always active. It was significant enough to bury a city and warrant a warning, but it sits well within Sakurajima's established range. And on the current evidence, it is not a precursor to anything categorically larger. What scientists will be watching in the days ahead is whether the activity continues to escalate, whether the alert level changes, and how the ash behaves as the wind shifts over the city. The deeper watch, the one measured in decades and centuries rather than days, is the slow recharging of the Aira caldera beneath the bay, a system that will, someday, do something far larger than what we saw yesterday, on a clock that almost certainly runs far beyond any of our lifetimes. The eruption we watched is the system breathing. The mountain will keep breathing, as it has for longer than any of us have been alive, and the city will keep watching it, 4 kilometers away, with its eyes open. We will be tracking this as it develops,